So session 1 in the morning will be by Professor Manjunath Pattabi. Professor Pattabi is the professor and chairman of the Department of Materials Science, Mangalore University. He was awarded PhD from IIT Madras on the thesis titled Aging Studies of Island Copper and Silver Films Deposited on Rigid and Softenable Substrates. So his research interests span a wide range of topics from thin films, nanoparticles of metals and semiconductors, to shape memory alloys, fuel cells and solar cells. He has been serving Mangalore University from 1988 till date at different capacities as lecturer, reader and currently as professor. He was also visiting professor at the CIA UNAM Mexico during the period June 1999 to June 2000. He has successfully guided 12 students for PhD and 5 students are pursuing PhD under him. He has completed 7 major research projects funded by various agencies like the Department of Science and Technology, Board of Research in Nuclear Sciences and so on. He is also the coordinator of the Center with Potential for Excellence in Particular Area program of the University Grants Commission UGC. He has published more than 80 papers in peer-reviewed international journals and presented several papers and also given talks in various international and national conferences. The awards and recognitions that he had received are, he is a visiting associate of Inter-University Consortium of the DAE Facilities Indoor during 1995 to 1999. He won the prestigious C.V. Raman Young Scientist Award by Karnataka State Council for Science and Technology, Government of Karnataka. He also won the MRSI Medal 2014 by the Materials Research Society of India. He is a fellow of the prestigious Royal Society of Chemistry, London. He has also visited various institutes in his tenure, to name some: Max Planck Institute, Stuttgart, Germany, National University of Singapore, and so on. He is the editor of the Advanced Material Science Research, Allied Academics, United Kingdom, and he is a member of the editorial board of Nano Hybrids and Composites, Transtech Publications, Switzerland. So we have an eminent scientist and an academician in Professor Manjunath Pattabi. Over to you, sir.
At the very outset, let me thank Professor K.V. Rao for giving me an opportunity to talk to the young students. Dr. Neelakantan, Professor Gangadharan, my friends, and all my young student friends. So this talk, when Professor K.V. Rao asked me to give something about India's achievements in the last 75 years, because quite often we ask, what is the achievements, or what achievements have taken place in the last 75 years? That's what we are hearing in the last few years too much, and everybody is asking, what is there? So India is nothing. It's not like that. We should take pride in India's achievements. And one thing is, it's very difficult to talk on this subject, because anyway, given the title, but it is almost impossible to cover this in a 45 minutes talk or 1 hour talk, because it requires 2-3 days seminar on this topic. But even then, I'm afraid you may not be able to cover everything. But then there's one thing, and then to put it in 1 hour's talk, again it's impossible task, because the time was very short. Only a few days back I was asked to give this talk, so the time constraint has, within the time constraint, whatever I am able to do. So please excuse me if I have left out many things, and here I am concentrating only a couple of things, mainly 2 things: space and atomic energy. And then of course I'll just giving you a glimpse of other fields also, because I understand most of your engineering students, and my idea is that you should be able to contribute to the growth of this country. This is the main purpose of this talk. Okay, so am I audible? Okay. So India's strides in science and technology from humble beginning to excellence. When I say strides is not just a few steps, it is a step with a decisive purpose. It's a decisive purpose. The steps taken after independence in a particular purposeful manner that is what has brought us to the present day where we are now. So, so that is what is the title of this topic. Yeah, no, that's down. Okay, because I was putting up. So, all of us know in 1947, August 15th, we became an independent country, right? So, Azadi Ka Amrit Mahotsav, 75 years we are celebrating now. The next question is that what have we achieved? So, I am trying to give a glimpse of this and who is responsible for that. So, what we had or where were we? That is the most important thing, because many have forget about you, even our generation, because when I was born in 1961, still some things have developed. So 1947, what it would have been, because we don't know. But Google tells us what is it. The population was 340 million. It was very, very comfortable. Population explosion was not there. But despite that, the literacy rate was only 12%. 12% literacy rate. And then per capita income was, that is 249 rupees per annum. So now you understand, when you say you can take into account the inflation, everything, but still 249 was a very, very meager income those days. And per annum. And I should tell you that my mother used to say, she got married in 1945 or so, and those days they had something like more than 75 acres of coffee plantation. But her father was not able to educate any one of them. The three sons, they got educated up to 3rd standard. That is what he could afford to with 75 acres of coffee plantation. And that is what, just to give you a comparison, because now even a coolie's children are able to study up to engineering or even medicine or anything is possible. So this is what, just for comparison. And the life expectancy was 32 years. And my mother again used to say that when somebody lives up to 50 years, they used to say that she has lived for so long. And that's what used to be the gesture or the expressions. So the villages having electricity was only 1,500 villages, and 0.002% of the villages in this country. And I was born in 61, and I left that place in 1974. Till that, our town didn't have electricity. It had a junior college, it had a post office, but didn't have electricity. So just for your understanding. And food shortage was there, housing shortage was there, communication was unthinkable, and then ill-equipped military. That is why 1948 we lost to Pakistan. That is a lot of land has to be ceded to Pakistan, and then China again we lost, and it's all because of ill-equipped army. It is not because of the strength of the army, it is the equipment that that was responsible. So the priority was, it was a great slogan even up to 1970s, that is Roti, Kapda or Makan. So these are the fundamental requirements of human being, and that is one thing, not the mobile phones, not the laptops, and these are all the present days things, unthinkable those days. Okay. So this is one thing, this picture, this is really the kind of, if you look at this, what is that fellow is doing? Trying to get some food from the waste bin. And still we have this kind of thing, but that was much more in those days. So then this is the roti, and you look at the children, of course they are slightly better dressed, and of course you have, but look at that, they are happy. That is one thing which all of us, the youngsters, we should remember. Despite having plenty now, we are not very happy. The happiness index is less, but those days they were happy. That is one thing. So Makan, these are the popular Makans, and then now we have, there are so many schemes for, housing schemes for the poor people. The government gives 3.5 lakhs subsidy for building a house if you have some land. So all these things are possible now because of growth. That is, so I hope all of you know this gentleman, and he was our first Prime Minister. Why I am talking about him? Not because of any politics or anything, because there may be so many things, but what he has done and all those things. I am talking about some things what he has done. These are the important things. I am talking about another gentleman I don't know how many of you know him. He is Lal Bahadur Shastri, the second Prime Minister of India. Of course, in between that some other caretaker Prime Minister was there. So these are the two people are there. So now where are we now? Population is 1.4 billion, may not be very good, but then literacy rate is 77.7%, the male literacy rate is 84.7%, female literacy also is 70%. It's quite good. And then per capita income is 1,35,000, that is about $8,800. It's not too bad, but still we are lagging behind Bangladesh, please remember. Then that is on PPP, that is purchase power parity. If you look at that, this is a different calculation because rupee, our purchase power is quite good because with the 20 rupees we can get a full meal. It's not possible for whatever you convert into dollars, it's not possible to get a full meal anywhere in the world. So that way it is 4,80,000 rupees. Then the life expectancy is 70 years. So in 32 years it has gone to 70 years. That is because of the healthcare. Despite the pandemic showing us that our healthcare system is inadequate, but despite that our health life expectancy has improved. That shows our healthcare facility is not too bad. And then villages having electricity, it is 5,79,012. It is more than 90% now. And when you say villages having electricity, at least 10 households should be having electricity in a village, and that's what is the condition I hear. And surplus food grains stock we are having, so that is there. Our Food Corporation India, lot of food is getting rotten, and we have surplus food. And I am told that even if there is a war or famine or anything, 1 year we can still have some food. So that's what it is. And Lal Bahadur Shastri, I think in 1962 or 65 or sometime during that war, so he gave a call to the people that at least one meal you sacrifice, even if you are able to afford, because food was shortage. There was a lot of shortage was there, food shortage was there, and because of that, and I remember my father, and until he died in 2003 at 94, he never used to eat on Monday night. It is because of Lal Bahadur Shastri's call for giving up one meal. So that is what is the importance of food. So I also tell you that don't waste food. Don't waste food, because when you talk about the food, recently I was reading that in some countries in Africa, the mud is mixed with salt and it's made into biscuits, and that is fed to the children and the parents eat. Just think of this. Just think of this. It's in the context of wastage of food, and this article was there. And just imagine, we don't have any right to waste even a grain of rice or food, because it is a criminal offense to waste. And that's what it is. We have sufficient food grain stock, and the housing, of course, it's not fully adequate, and the communication and our cell phone connection is 1.15 billion now, the latest in 2021 connection. And smartphone is 492.78 million, and we are second in the world in terms of the number of smartphone connections. But then the reach or the penetration in the village, it's only 35.4% of the population, because our population is very large, 1.4 billion, and in terms of the number of smartphones, we are second in the country. We are only next to our friend People Republic of China, and with 953 millions and 66% reach. United States with only 273 millions, but they have 82% reach or the penetration. Indonesia with 170 millions with 61% penetration, and Russia with 102 million with 70% penetration. And in terms of the penetration also, we are in the 19th position. We are in the 19th position. You may be seeing ordinary people, in the sense the rickshaw drivers or even some of the coolies or anybody will be using the WhatsApp, etc., the internet they are using, the smartphone they are using. And this is seen, it's amazing development. It's an amazing development. If you had seen about 30 years back, many households, 30 years back, not many years back, many households didn't have a phone connection, To get a phone connection in my house, I had to wait for 2 years. 2 years I had to wait for the landline connection in 1988. So then, of course, we have military, we have many indigenous missiles, ships, submarines, everything was possible. So this is what it is. How many of you can recognize this person? Yeah?
So he is Dr. Varghese Kurian.
Varghese Kurian, yes. He is, no, I normally say that's another person. Any guess? Any guess? Dr. M.S. Swaminathan. Dr. M.S. Swaminathan. I normally say these are the two people, in Kannada we say Pratasmaraniyar, because every morning you get up and remember these people. They are like gods to us, because one person is responsible for white revolution, and if you are having sufficient milk for us, that means this person is responsible. And of course that also was possible because of Lal Bahadur Shastri. That's why I put his photograph there. And this person is responsible for the sufficient food grains. If we have food on our plate, that is because of this man. And we may be talking about various things, because we may be talking about the hybrid varieties of rice and all those things. This has spoiled our health, and many things we are being told. But then, despite all this, the life expectancy has increased. Please remember that. Don't forget that. And we can talk about organic food, we can talk about pesticide free, we can talk about chemical free food, everything we can talk about after we have sufficient food. When you are hungry, when people can eat even the mud with salt, then you don't think about whether it's chemically sprayed or whether it is grown with chemical fertilizers or anything. You don't talk about that, because at that time all that was required. Now we can think of various methods of growing organic food in a better way. That is a different thing. Okay. So these are the two people. So Varghese Kurian, he was a mechanical engineer, because many of you may be mechanical engineers here. So he was a mechanical engineer from Madras, I think Guindy Engineering College. And then his option was to join Tata Steel, because his uncle, one of his uncles was a minister in central government. One of his uncles was the director in Tata Steel. So easily he could have got into Tata Steel. Maybe he would have become GM or CMD or something like that. But anyway, that was his option. But then he was sent to Imperial Institute of Animal Husbandry in Bangalore for a training of 9 months. So that is by his uncle, because he had a different thing. So he wanted to get out of his uncle's stretches. So he got a Government of India scholarship to study in US, and that is in dairy engineering. That was the only fellowship which was left. There is only one fellowship which was left. So he got into that fellowship. Finally he was destined to be in dairy. So that's what it is. That's what I would say. So he went to Michigan State University, but then he says, I did a small trick to get masters in mechanical engineering instead of dairy engineering. Somehow after going there, he was able to get into that. So then he says, I was sent to study the dairy engineering on the only GOA scholarship left. I cheated a bit though and studied metallurgical and nuclear engineering disciplines likely to be of far greater use to my soon to be independent country, and quite frankly to me. I put the whole sentence of him, because normally I don't like to put this one, but I put this because look at his frankness. Look at his frankness. All of us are finally, we are selfish also. At the same time he was thinking about the country. But anyway, after coming there, he was sent to Anand for a Government of India establishment for an experimental creamery, that is in the milk industry. And then he got into contact with one Tribhuvandas Patel, who had a primitive dairy equipment in Bombay. So he used to go during the weekends from Anand to Bombay, and then he used to associate with him, and that fellow formed a cooperative to purchase that is the milk in the nearby Kaira district. And then he left his government job and joined this movement, and that movement is called as Kaira District Cooperative Milk Producers Union, popularly known as Amul, and which is now Anand Milk Utpadak Limited Dairy. So that is what it is, and all of us are fond of Amul. And many of the in my generation, children have grown, when they don't have sufficient milk, they have grown with this Amul milk powder also. And of course now you grow up with milk chocolates, and that's what it is. And we are now the largest milk producer in the world. A few years back we were the second largest producers, and now we are the largest producers of milk in the world. And that is possible because of the sustained effort of there's Amul dairy, and all our Nandini are various dairies. They're all subsidiaries of this, the National Dairy Development, and the National Dairy Development board, NDDB, and he was the chairman until very ripe age, and he was contributing to that. That's why I said he should be remembered, though it's not topic of today's talk, but you cannot forget about this. Milk and food we cannot forget. That's why I'm talking about this. And our production is 22% to the world contribution, and followed by USA, China, Pakistan and Brazil in the milk production. And that's what we should say. We should take pride in that, and that is possible mainly because of one person, and it was supported by Lal Bahadur Shastri, because he went and stayed in Gujarat near Anand, and he was the one who prompted the people to establish a cooperative society, that what you say, Grama Vastavya. These days people talk about that, and he did only once this Grama Vastavya, and the outcome is this. And you ask anybody, you do Grama Vastavya, what do you learn? You can also go and stay in some villages, and what you learn from that, that is more important, and that's what it is. So M.S. Swaminathan's parents wanted him to study medicine. So he was worried, always interested in farmers' problem, so he wanted to study zoology, and I think he studied in at Maharaja's College in Trivandrum. Then he came to study in, then he, see, when he was a student, even though he was interested in farmers' problems, particularly the pests, etc., that's why he wanted to study zoology. Maybe he wanted to be an entomologist, but then the Bengal famine when he was a student, and the Second World War, the food shortages, etc., that prompted him to devote his life to ensure India had enough food. See, as a student, he had that goal to do something to the country. And why I'm telling all these things is that, so you are students, you are young minds, so you can think now in terms of contributing something to the country. In the process, you also will be benefited. Don't think that you will not be to do a selfless service. Your self-interest also will be taken care of. After studying agriculture, he was selected to IPS, Indian Police Service, those days the civil service. So he was selected for that, but it was not for him. He chose genetics through the UNESCO fellowship at Netherlands, and then now because of that, his contributions, we have surplus food now. So that is why I said Pratasmarniyaru, every morning you think of these people, and I tell my students also, these people cannot be forgotten. Then I said Jawaharlal Nehru, he built many temples. Of course, this was built much earlier, University of Science, which was built in 1910, I guess. That's because of the behest of Swami Vivekananda to Tatas and J.R.D. Tata. So that is one thing. Then this is IIT Kanpur, Kharagpur, and this IIT Bombay. Then IIT Madras, my alma mater, IIT Delhi, and then TAFR was there at the behest of Homi J. Baba, and then our own NITK, because you can put so many NITs, but I put only this one because there is no point in putting so many things. Now you have so many NITs. Those days it was regional engineering colleges. Why I have put is these temples produce the students. Many of them might have migrated to the Western countries for greener pastures, but then many have stayed back in this country, and they have contributed to the growth of this country. And you also have, and those days private engineering colleges and other engineering colleges are not there. Don't feel that only IITs and NITs, they are good. You are also good, provided you make yourself good enough. That's the only thing. Institutes won't make anybody good. You have to become good with your efforts. Anybody can be a good student, anybody can be a good engineer. That's what is important. So this is sustainability. In addition to the growth, we also have to think of sustainability. When you think of sustainability, we also have to care for the environment. So I have shown only the solar power and wind power, and in addition to that, there is another thing. Of course, this is very good, but it will take long time to go, and that is why in the meanwhile, what you can do, and that's what it is. So the energy source type, the coal, you have the tons which is available is 54 billion tons which is available. If you think of the power potential, this is terawatt electricity per year, that is year in that units, it is 11. You have hydrocarbons, 12 billion, it's only 6 now. Uranium in pressurized heavy water reactors, 61,000 tons are there. It was only the estimate 0.3 to 0.42. Uranium in fast breeder reactors, the same thing, you can go to 16 to 54 terawatts. And thorium, we have more than 300,000 tons, and the possibility is 358 terawatts here. This only initial estimates. And we come to this atomic energy. You can't forget this man, Homi Bhabha. Again, this all, he was very wealthy. He could have been anything what he wishes if he had stayed back, the various things, and let us look at that. He was the founding director and professor of physics at the Tata Institute of Fundamental Research, and that was, he gave a proposal to the Tatas to start this institute, to start the nuclear energy program. And then, that is why he is considered the father of Indian nuclear program, and the founding director of Atomic Energy Establishment Trombay, AEET, which is now called as PRSC, which was renamed afterwards. And then TFR and AIT were the cornerstones of Indian development of nuclear weapons, which also he supervised. The Homi Bhabha was awarded the Adams Prize, that is a prestigious prize, and the Padma Bhushan. And then he was also nominated for the Nobel Prize in Physics in 1951, 53 to 56 for his contribution to the cosmic ray research, and also for the mesons, I think. Now, the meson name is given by him. And then the uranium deposits. So now it is known that 78,000 tons of uranium metal is there, and this many tons of thorium, and the natural uranium fueled pressurized heavy water reactors, which can produce 420 gigawatt years, and again depleted uranium and separated plutonium from pressurized heavy water reactors in fast breeder reactors. And Bhabha envisaged three phases of nuclear energy programs, so that first place one thing, second is another phase, the third phase, and I think we are now in the second phase. So that again can produce so much of electricity. Now you can look at the numbers now, how much electricity is possible. And then in these fast breeder reactors, the production of uranium-233 from thorium-233, and can also be achieved by loading thorium assemblies in their blanket, that's a byproduct kind of thing. And then eventually the generations of thorium uranium fueled breeder reactors, an additional 350,000 gigawatt years of electricity that is possible. So that's what is the program. So thus, even with an installed capacity of 500 to 600 gigawatt electricity, the country's nuclear resources will be able to sustain the electricity generation needs far beyond the extinction of its coal deposits. That's what is estimated, that's what is believed. So this is the first Apsara reactor, which was an experimental reactor, which was produced, it was made in the AEET or BRC now. So the milestones of atomic energy. So just let me give a brief milestone of atomic energy. So if you look at this, this is major events, the green ones are major events, and then the red ones are nuclear power stations, and this is the reactors, and this is the heavy water plants, and the important ones I put it in blue. TFR was established in 1945, and Atomic Energy Commission was formed later on, and 1950, that is this IREL is established. And then DAE was named, a department is formed in 1954, the Apsara reactor was made in 1956, and then the uranium production at Trombay, which began in 1959, that is a major milestone. You would have heard the Pakistan stole the technology from US, and still they were able to do that, but we have our own indigenous developments. And then what other important things? You have the breeder reactors, and Zarlina again was an experimental reactor, and IGCA, the Indira Gandhi Center for Atomic Research, was established in 1974 at Kalpakkam, and 1974 the Pokhran first, the Smiling Buddha, that is the first bomb was tested. And then of course after this Pokhran blast, first one. So we got the sanctions. I hope you understand what you mean by the sanctions. And the Atomic Energy Department, of course, India as a whole, Atomic Energy Department particularly, and the space programs. Many of the technologies were not being sold, many of the instruments were not being sold, many of the materials are not being sold, and even small bolts and nut is also not being sold. because our Tarapur plant was shut down for long time for want of certain bolts and nuts, and they were not being manufactured in this country, and the other developed countries were refusing to give us the technology. And after this date, 1975, till date, we are not getting, not only after the recent second Pokhran blasts, which was tested in 1996, 98. So not after that, even after 1974, we have been facing the sanctions in key technical areas. To just give you an example, all of you might have heard of a scanning electron microscope. Scanning electron microscope, the best company in the world is Carl Zeiss. They are not supplying even now to atomic energy and space programs. They are buying Czechoslovakia make, that is T-scan or something like that, because when we were buying the SEM, that time only I came to know, because atomic energy and space department, they are procuring only from the Czechoslovakian company, not from Carl Zeiss, because these countries like UK, USA, etc., they are not supplying because of the sanctions. So this is what it is. So then you have various kinds of reactors and breeder reactors, and all these are with a purposeful proposition. They have been able to develop the phase 1, phase 2, phase 3. Phase 3 is to make use of the vast deposits of thorium, which is available particularly in our monazite sands. I am told our Kerala is full of this monazite sands, and from that it may be a very small quantity in terms of the percentage, but then it can be so many thousands of tons which is available, which can give us so much of electricity. So that's what it is. And at that time, somebody told, during Baba's time, somebody told atomic energy, that electricity from atomic energy, that is power, is very expensive. Then he told one thing: no power is more expensive than no power. That is, if you don't have any power, it is going to cost you much more than having any expensive power. That's what is the idea. So that's what it is. So then, anybody can recognize this face? Anybody can recognize this face? It's Vikram Sarabhai. So he is considered as the father of Indian space program. He is considered as the father of Indian space program. Again, he was from a very wealthy family. They had a very big business in chemicals. Now also Sarabhai Chemicals, it is there. So he was also he also could have taken to his family business, but then he started the physical research laboratory that was founded in 1947 by him at his residence. You can just imagine, now we are thinking of funds, we don't have facilities, we are talking about various things, but then he started something in his residence, and Professor Kalpathy Ramakrishna Ramanathan was the first director of the institute when it was formally formed outside. So then, it's not only that, see, this is the people who are the visionaries. He started Operation Research Group, that is for supply chain, etc., what we talk now. Then Nehru Foundation for Development in Anand, Indian Institute of Management at Ahmedabad. So we talk about all these big institutes. These visionaries started, and of course, when he started, of course, the government which was there, that has given the support, the prime ministers. So that's why I put those photographs, not for anything else. Textile Industry Research Association, because Gujarat is known for textile industry of that stretch. Then Darpana Academy of Performing Arts, because his wife Mrinalini Sarabhai is a very great artist, and their daughter Malika Sarabhai, she has written a very nice book on Bharatanatyam. That's a very classic book. So these visionaries, they contribute to various fields. That's what is to be noted, because if they are able to contribute to so many fields, why can't you contribute to at least some field? That's what you people should think. Okay. Then fast breeder test reactor at Kalpakkam, then variable energy cyclotron project at Calcutta, then Electronics Corporation of India Limited, ECL, it's a government of India enterprise. They used to do a great work, particularly in the older generation of electronics. I don't know how it is now, but then that is for all the electronics required for the atomic energy projects, they were able to do that, maybe possibly for space also. Uranium Corporation of India Limited for mining the uranium and also purifying, etc., for that one. And of course, you have various other atomic energy related, Atomic Energy Minerals Limited is there in Hyderabad. Where if you are working in other areas of research, when you want 99.999% of gold, silver, selenium, tellurium, etc., you can get it from Hyderabad at 1/5 of the cost at which you can buy from Aldrich or that is Sigma Aldrich companies, because even though it's little difficult to buy it through that bureaucratic process, they asked me to go and buy personally because they don't want to supply and by post or anything. They said it's a precious metal, I want to buy some silver. So all these bureaucratic systems are there, but still in 1994 when I just was starting my research, what I could buy for 10,000 rupees, Aldrich, the quotation, if you look into that, through that it would have been around 80 or 90,000 rupees. So that way, and the quality is as good as Aldrich or Sigma. So that is the one thing which you have to notice, and all that is possible because of this man. He started a project for the fabrication and launch of Indian satellite. So he had the vision to start a space program, and for that of course he has also got the support from the government, and they are able to do that one. So he was the founder of the Indian Space Research Organization, and you would have heard Dr. Kalam, our former president, talking at various platforms. He was talking about Sarabhai because Kalam was picked up by Sarabhai to lead that missiles or the rocket technology. So this is where the Indian space program started. This is in Trivandrum, and that place is called as Tumba, I think. And see that this is a church, and they started this program in a church, and the priest of the church was kind enough or good enough to spare the space or the place for this space program. And then later on, when it was found that that is the only place which is suitable for that for their activities, he also agreed to give that land and the church and go away for their religious activities elsewhere. So that is the greatness of those people, and I don't remember the name of that person. So this is this is the rocket being taken for launching. Rocket being taken for launching. This was the humble beginning. Okay. So then this is another one. So this is the way the rockets were being taken for launching. Okay. So then, what is this? Satellite. So if I tell this without the pictures, you would laugh at me. It will be like a fairy tale. Okay. Particularly, you're all born after 2000, right? So even if I say something, some of the technologies what was there during my childhood days, you would laugh. My children would laugh. So this is what was the technology. So the milestone launchers. So you have this sounding rocket. It was called as a sounding rocket. It is about 3 meters and about 10 kgs. I will tell you this one. So then I put only a few things. This is SLV3. Then of course then after that advanced SLV, Space Satellite Launching Vehicle. Then you have the PSLV. PSLV3 was the most successful one, and then of course what is put is only the XL, the much higher versions. So then you have GSLV, that MK3, that is the latest one, and GSLV Mark 3, that is Mark 2 and Mark 3, that is the latest ones. And the first row tells you about the height from 3.59 meters to 43 meters. The lift weight is 0.1 tons, that is 100 kilograms to 640 tons, and the payload from 10 kilograms to 4,000 kilograms. Payload from 10 kilograms to 4,000 kilograms. And again you can see this is low Earth orbit. I think it's only a few kilometers. That is a few kilometers it was. There was a solid propulsion engine and solid and liquid propulsion, and this cryogenic engines. And you would have heard of all these names, and for bad reasons also. So there was something you would have heard of Dr. Nambi Narayanan. So the story, and that's all in connection with this one, and I understand that without that episode, Nammi Narayan's episode, we would have been much faster. That's what, there is a conspiracy theory also. So anyway, let's not talk about that. So all these rockets, when you say PSLV, Polar Satellite Launching Vehicle, what do you mean by Polar Satellite Launching Vehicle? No, the orbit of this satellite will be from north to south, through the north and south poles. It goes twice a day. So it, if you put that satellite in that orbit, so that will pass through the Indian subcontinent twice a day. That's what is the thing. And you have another thing which is called as geosynchronous. So at 36,000 kilometers, there is the geosynchronous orbit, and this polar orbit, I think it's only a few thousand kilometers, 1,700 kilometers or something like that. And this is at 36,000 kilometers, the geosynchronous orbit. That's where all the time it is synchronized with our Earth's orbit, Earth's rotation, and all the time it is looking at only one point. So that's what is a very advanced technologies, and that's what it is there. Then ISRO's timeline of space program. So the 1963, you have the sounding rocket, that is on November 21st at Tumbe station, it was done. Then 1975, Aryabhatta, that is the first rocket, satellite was launched. That is 1975. That time we were in high school. So at least I remember about that name, Aryabhatta. And that was launched from France, I think. And then we have 1979 Bhaskara. That's, I think, again some studies, because most of these were for studies, not for any other programs. And then SLV-3 in 1979, 1980 Rohini, that's another satellite. That INSAT-1A, that is, I think that's a communication satellite. That was in 1982. 1987, again ASLV rocket was there. Then ESROS C, these are all the different names using ASLV. Then that IRSP-2, that is again PSLV rocket, and that was for development. And the GSAT, that is Geosynchronous Orbit, that is the first one at 2001, and of course many failures should have been there. But then Chandrayaan 2008, India was able to send the rocket to moon. So next important thing, of course many things I have missed here. So in between, how many, all these numbers there, 3, 2, 5, 4, 6, etc. These are the number of satellites which have been sent in between that period, because otherwise it will become too crowded. That's why I didn't put that slide. Okay. So then you have this MOM, that is Mars orbital mission. So orbiter mission, that is just going to the Mars orbit, and that you should remember that India is the first country which could do that in the first attempt. You can pass an examination, IAS examination or whatever examination, CA examinations after so many attempts, that is different. But doing it in the first attempt and being first, that is something which is to be appreciated. So that's what is the first attempt, and all that had the humble beginning here, 1963. That is that sounding rocket, and I think even now for public they show that sounding rockets. They demonstrate that one in Tumba. All this GSLV was there, Astrosat, and then again you just see now that 9 satellites were they put in the geosynchronous orbit, and somewhere here 104 satellites were put in the orbit in one rocket. It's not a small achievement. Putting one satellite in the orbit itself is a great thing. And of course it is assisted by Hassan. You have master control facility, that satellite control facility is there in Ahmedabad. You have various facilities, but then again, to make the satellites, all the satellites are made indigenously. Here I should tell you that our remote sensing for various communication satellites are there. Our 4G, 5G, all that is possible because of our own communication satellites. Otherwise, you have to pay heavily for the bandwidth if other countries' satellites. So now we can sell them. And not only that, India is able to launch the satellites of other countries, of course, for a fee. So I think this 104 satellites, all from foreign countries, for the countries like UK, Singapore, various countries are making use of our launching facility. So this is one thing which all of us should be proud of. And again, this MOM orbital, that is it, when that was successful, I was there in Coorg in a hotel, we were seeing that one, and immediately after the successful, I called the secretary of then Isro chairman Radhakrishnan. He had come here, so I knew him. So just to convey my congratulations. So his secretary is from Kasaragod. So then he didn't reply. Then after a few minutes he called me back. He said, just they were there, Prime Minister was there and all that. So then I told him, I just called you to convey our appreciation and congratulations to the chairman. Then I asked him how long it took for the government of India to approve this project. It was one of the cheapest missions. I think $500 million or something like that. It's one of the very cheap, or 500 crores. It's a very small amount compared to the amounts spent by other countries. So I asked how long it took, but still it is in hundreds of crores. How long it took for the sanction? 1 month. No, you have to appreciate the government also. Dr. Manmohan Singh was the Prime Minister at that time. So that is one thing all governments have supported. This will not happen overnight. What you should understand is from 1963 till now, whatever has happened, the governments have given active or passive supports. It was happening. So, but the people and the scientists with the determination, they have worked. And who are those people? They are not falling from the sky. They are like you. So you should be able to see after a few years where you will be. Whether you will be writing only the softwares for maybe whatever kind of programs, or you want to contribute for these programs. This is what you should see. So this is that moon, sorry, Chandrayaan, that lander. So this is the celebration, the Chandrayaan success. Sorry, not the Chandrayaan, that Mars. Okay, Mangalyaan, sorry. And I particularly put this one for, I know at least a good percentage of our student community is women. So don't think that it's not for us. So there are quite a few women scientists there, technologists. They all have contributed, and they have even the missile programs. There are, I forgot her name, some Tracy or somebody from Kerala. So they have even led the programs. So every one of you are capable of getting into these programs and leading those programs and contributing to the country. This is what I want to say. This is our Tejas. It took a lot of time. Light combat aircraft, which is developed by, anybody can say? Hindustan Aeronautics Limited. Hindustan Aeronautics Limited is a public sector company. Again, most of us as public, we feel that these public sector companies, many of these public sector companies are not doing anything. They are not doing anything. And I was also wondering until maybe 20 years back, what this HAL has done. Hindustan Aeronautics Limited, we are not producing even a single aeroplane. We are all importing. So what is that we have done? And this HAL, of course, they have been developing for a very long time. And when you talk to the people, you realize that the DGCA control is so much. Even if it's 1 kg extra weight, they will not give you for flying permission. So to reduce that weight, again you have to design new materials, design new components, and all these things which is given by the National Aerospace Laboratories, NAL, Bangalore. So this NAL and HAL, NAL produce the materials for these materials you don't get from abroad. So they produce the materials, and they have taken, I think, I don't know how the exact number, more than 100 patents for this LCA alone for the materials. And that is one thing, particularly the composite materials. And then there is NAL, HAL, and again this HAL, I came to know that they are doing some good things, because two of my students joined HAL after some long time. When they came here, I was asking, what is your work? I thought they don't have any work. And one fellow, he was, he is the manager for one floor which produces the aircraft belly, which they are exporting to England. I think the Boeing is England, this company, and they are exporting to Boeing. So then only I started thinking, you think of that material, that one belly, it should not have any welding joints. It should not have any welding joints from the engineering point of view, because inside the pressure is atmospheric pressure. Outside is at a 10 power minus 5 torr, 10 power minus 10 torr. It is that range, 10,000 kilometers when it goes. So 10,000 meters, 10 kilometers when it goes. What will be the pressure outside? It is in terms of a very, very small fraction of a torr. So what will be the pressure difference? What will be the pressure difference? It will explode. So that kind of capability our people are making here. It's not that they are not doing anything. The only thing is that we don't know what's happening there. Only when the product comes out, we know. Only when the product comes out, we know. Again, the scientists, or Venkatraman Ramakrishnan, when he got Nobel Prize for crystallography, he told the same thing. Last year, I was here. I had done this work much earlier. I was here giving talk in Bangalore and various places, and nobody bothered about me. Now that recognition came, they are bothered about me. The same thing, my another friend who is a professor in MIT, when his field got Nobel Prize, the Nobel Committee mentioned his name twice. So that time in US, CNN, BBC, etc., they were trying to contact his wife. He doesn't carry a phone, a mobile phone. He never used to carry at that time. So there was 2006, I think. So they were contacting his wife. They want an interview with him. But he was in Bangalore. Nobody knew about him. And he has come to various colleges here. So next time when he comes, maybe I will bring him here also. So that is the kind of person. He has come to NIT a couple of years back. So Jagdish Modera. So the thing is, we have the capability, and all these capabilities are not mean. And all this, again and again, I am stressing that people have not come from abroad. Indian engineers and technocrats, scientists have gone abroad, USA, various countries, and contributed to their growth. They got Nobel Prize, they got technology they have gone, and we are talking about Sundar Pichai, various people. So that is different. Like that, the bright brains we didn't get from abroad. We have our brains which are made into bright. Our brains have been polished and made into bright. So all of you are bright students. Only thing is that you have to make it brighter, thinking that I can do such things. That's the only thing. Okay. Then our BrahMos missile. You know the name BrahMos, it comes because of our Brahmaputra, and this is a collaboration project from USSR and India, and Brahmaputra and Moscow, two rivers. From that it is the BrahMos. And for BrahMos again, getting money is not that easy. Who funded this? Not the government of India. It is funded by Syndicate Bank. BrahMos. It's a corporation, and it was funded by Syndicate Bank, Manipal. They funded for this project, and recently I saw in the newspaper that I think South Korea bought 2,800 crores worth BrahMos missiles from us. So we started selling now. Earlier we were importers of defense equipment. Now we are exporters of defense equipment. So this is one thing. And LCA also, I think recent Aero India show, there are so many inquiries for that. So now it is inducted into our Air Force, and very soon it is going. Once it is successfully shown by our Air Force, definitely it will be having demand for purchase. Then we don't have to buy from outside. So BrahMos missile, that is the fastest cruise missile in the world. Fastest cruise missile in the world. So that is, but its range is not so much. I think 300-400 kilometers or something. But then our Vigyan tank. This has been there in our our army, I think since 1970s. Even in 1972 war, Vigyan tank was there in action, and it was competing with America's Patton tank. America's Patton tank, which is a very deadly tank. And you would have heard of I forgot his name, some Subedar Major something. He was responsible for killing 100 and odd fattened tanks in Punjab, that sector. Okay, and American military history never talks about that particular battle. That is called as Asal Uttar. This is called as Asal Uttar. In Hindi, that battle is called as Asal Uttar. I think that place is, I forgot. And that is being taught in every textbooks of military colleges. Every textbook of military colleges except America. It is because fattened tanks, so many fattened tanks were buried there because they were killed. The tanks were destroyed. And our Vijayanta tank is capable of good performance. Then you have this Agni missile. You have Agni 1, 2, 3, 4, 5, etc. This is the world's most cost-effective ICBM, intercontinental ballistic missile. With a range of 5,000 kilometers, 5,000 to 8,000 kilometers. So even the China's farthest targets can be reached by Agni 5 with a nuclear warhead. So these are all indigenously developed. Things, and we can talk about of course there are various missiles, and this missiles program, and of course for the rocket program followed by missiles program was led by our former President Abdul Kalam, and this is one small story. Then I can tell you about the remote sensing satellites. Somewhere I mentioned and then I stopped. The remote sensing satellites. The remote sensing satellites, when the Pokhran second blast was in 1998, America's satellites were not able to get a clue of this. Have you read that on newspapers? Oh, you are not born. But America's satellites were not able to get a clue of this one because of their lack of resolution. Of course, when I say resolution, all of you know about resolution now because of the mobile phones. And because of the less resolution of American satellites, they are not able to that one. But our Indian satellites have much better resolutions than American remote sensing satellites. Many years back it was 1 foot. And our remote sensing pictures, if you see, if your car is parked in front of your house, if the proper lighting and all is there, you can read the number plate. That is the resolution. And the important thing there is the camera, and in that camera you have the lenses, and of course various lenses will be there, many lens elements, and there are various aberrations and reflectances which take place. The light gets reflected. Here in this case infrared radiations from the earth, which is reflected from the earth's surface. So that is being taken. This is germanium lenses, and you need coatings which are called as anti-reflection coatings, and these anti-reflection coatings also along with the lenses were also done in our Isro Bangalore Pinya Center. 2 of our students are working there. That's how I know the resolutions, etc. Because you require this anti-reflection coatings which are there in all our cameras. So that is for the reflection to be reduced from 4%. Glass has 4%, depending upon the refractive indices of materials and the medium. Anyway, all these technologies are there. They are developed by students like you. One time they were students like you in our own colleges. And they could get into these organizations either by choice or by chance. Both are there. So with this they could contribute to the growth of this, and these are some of the strides taken by the Indian science and technology. And this I just stop this talk. If you have some questions, if there is time, maybe I can answer a few questions. Not that I am an expert. Okay, let me try to answer. So I thank this fellow. He keeps with me all these days because the time was very short, up to 11:30, 12 if I sit for preparing the slides. So he sits with me, so I thank him more than anybody else. So thank you, Ananda. So a few questions, maybe I'll try to answer.
The floor is open for discussion. So, anybody, students and faculty, anybody, if you have any doubts, you can ask, please.
You people should really think in terms of research, development, etc. So day after that, this Monday, National Science Day, one of my friends is giving a talk now online. He's in Australia now. He is the one who has developed the Tata Swachh water filter. So when it was being developed at Tata, TCS, Tata Chemicals Innovation Center, I had been there. So it has only two main components, silver nanoparticles and umikari. Umikari is the rice husk charcoal. Okay, these are all known to us. But that is the cheapest water filter in the world. And that development took about 2 years because he is an expert in nanotechnology with over 50-60 patents to his credit. So anyway, the thing is, every one of you can aspire to be contributing to the growth of this country. That is the message. If there are no questions, thank you once again the organizers and all of you for patient hearing.